promptly because I'm going to attempt to cram an incredible amount into 2 hours. We'll see how it goes. So this is billed as TensorFlow coding workshop, and just kind of due to the short amount of time we had for it, and the fact that you kind of just need a little bit of intro to what's going on in TensorFlow before you can get anything out of using it. There's not actually going to be a whole lot of coding. I would call it more like, hands-on installing and running little programs, and not much time to actually generate stuff on your own. But I'll point you to a lot of places where sort of now you've got jump started, you can go off and do that in the future. And this room is also not very optimally set up to do hands-on stuff, and I think if you, no tables, no PowerPoints. So I think that if you just want to watch instead of like playing a lot of hands-on, I think you probably will still get a lot out of it. So it's kind of up to you as to what. So it's 2 hours. We'll take a little break, kind of midway through. And my name is Amy Unruh. I work for Google. I'm in developer relations for the cloud platform. And I focus on a lot of stuff in cloud, but right now I kind of have a focus on the cloud platform, big data, and machine learning products. So I've been doing a lot of work in this area, including working on TensorFlow. Okay, so here, I'm not sure how well you can see this. On a lot of the slides, there's going to be a footer that, a footer that points to the slides themselves. So you can read that. That's another reminder of where the slides are, and I'll put up a page that has that information in just a second. Here. All right. So here are the slides. The GitHub repo that we're going to be working from is here, and it is, as you'll see when you go look at it, it has a ton of stuff, much more than we will cover in 2 hours. But if you are interested and want to explore further, poke around in this big repo more in your own time. And it's also going to be it's kind of a growing repo. If you want to keep an eye on it, it's going to have more stuff added over time as well. We use it for a number of our TensorFlow projects. Okay, so let me take a little bit of a poll just to see what experience you guys have with this stuff. First of all, who is used to working with Python? Okay, great. Who has done a little bit with machine learning before using something? Oh, great. Okay. Who has used packages like NumPy, who's used scikit-learn? Okay, good. All right. So I think a lot of this might make sense to some of you without too much background, which is great. Okay. So what we're going to try to do in this 2 hours is first go through like a little bit of intro stuff to kind of set the context of what's TensorFlow, something really high level on what's machine learning, and make sure everyone who wants to gets everything installed properly. And then once we're ready to go, we'll first go through kind of a little bit of a starter exercise, just to get used to working with TensorFlow. That's not even building a neural net, just kind of to play around with it. And then we'll go to building a very simple linear classifier using what is often described as kind of like the hello world of machine learning, as this task called MNIST. to try to learn to recognize handwritten digits. And then, as time permits, and I hope we'll have enough time to do the next step, we'll take a vote. We'll do one of two things. Unfortunately, I don't think we'll have time to do both. We'll see. One is to build a deep neural network MNIST classifier, and the other is to do a fun kind of a fun exercise to do transfer learning, kind of piggybacking or bootstrapping off an already trained TensorFlow neural net. So we'll see how we go. See how much time we have. Okay, so here is the setup and installation. And I'm going to give you guys just a little bit of time, like maybe 5 minutes or so, to start doing this now, if you haven't done it already. Who has done it already? Oh, great. Okay. Actually, almost all of you. Let me ask that. Who hasn't done it yet? Who can say what to do? Okay. Great. Not very many of you. All right. So I think what I'll do is let's just give you a few minutes to make sure you have the repo link. You can get to the repo. You can clone it. You can get to the instructions. And then I'm going to start just kind of plunging into some of the intro stuff. And those of you who haven't installed yet can kind of work away on the slide at installing while I do the intros. So let me just give you a few minutes to make sure everyone has the context. So, and let me say a few words to Windows users. How many Windows users are there? Okay. So with TensorFlow, up until the very most recent release, which just came out last week, or was it this week? I already lost track. You basically had to run TensorFlow on Windows in a Docker container. So just as of this most recent release, 0.12, you now don't necessarily need to do that. I haven't tested driven this myself, but supposedly you can just install directly. So if anyone gives that a try, let me know how it goes. If anyone wants to run in a Docker container and has any issues installing Docker, our expert here can help you. Okay. Oh, yes. Yay, Kubernetes. Another one of my favorites, Google.
One down.
Okay, so does everyone at least have the information on this slide? They found the repo, they found the installation instructions. They've got a link to the slides if they want it. Okay, great. So, what I'm going to do then is again, just go through a little bit of intro stuff, and then if you're having any problems with the installation, we can catch up a little bit later, like during the little mini break that we take between the 2 hours, and we'll make sure we get you set up. Okay, so because this is a GBT dev test, I thought I would just say a little bit about quick about the cloud platform stuff and where TensorFlow fits into it. And so I'm not going to describe all of this, but to sort of get a sense, most of you probably at least have some passing familiarity with what the cloud platform has to offer. But kind of roughly you can group it into compute, like app engine, container engine, compute engine, storage, things like cloud storage, big table, cloud SQL, big data, a lot of fun new stuff coming out there, BigQuery, pubs out, data flow. These are very cool if you haven't played with them. And then machine learning. And the machine learning group is a little bit out of date in this slide, so I'm going to quickly move to the next one. So there's kind of two things going on at Google in the area of machine learning. And so one is a set of kind of, I guess, pre-baked is the way to put it, pre-baked APIs that you can just use. They're really easy to use from the mobile app. They're really fun. They're really powerful. Underneath the hood is a very powerful set of models training on a lot of data. So did anyone see Jason's talk earlier today where he talked about that a little bit? Okay, yeah. So I won't spend any time on these. Vision API, speech API, natural language API, translation, they're really fun. If you're not familiar with them, check them out. Okay, and then kind of at the other end of the spectrum is building and training your own models. So TensorFlow is a framework to do that. And then the CloudML platform, which I'm not going to really talk about today, mostly just due to lack of time, is essentially, so TensorFlow is open source, as you'll hear about more in just a second. And then the CloudML platform is essentially a Google-hosted way to train and to serve your TensorFlow-based models. And again, just due to lack of time, I'm not going to be able to say too much about it. But it's very interesting as well to play with that, check that. It's in beta right now. Okay, so what is TensorFlow? Why is it so great for machine learning? So it's an open source machine intelligence platform or framework, and you can find all the information about it. Sort of the starting point is at TensorFlow.org, including pointing you to the GitHub repo. And so it's particularly useful for doing so-called deep learning. And so that's what I'm going to talk about today. But it's good for other kinds of computation and other kinds of learning too. So I know it's gotten a lot of buzz in the press. As being, here's how to build and train your neural nets on TensorFlow, but it's a little more general than that actually. But we're just going to focus on the neural net aspect. So just as kind of a teaser of some of the stuff you can do, that's really an eye test slide with this projector. Here are some models that the Google team has, TensorFlow models that the Google team has open sourced, meaning you can find them, you can play around with them. So the links are in the slides. There's Inception. This is an image classification model trained on 1,000 different categories of images. So, and it's been released. The release, what's been open source, includes the trained variable weights. So it's sort of all ready to go. You can feed it images, and you can see what it thinks they are. It's really fun to play with. If we have time, we'll do a little bit more of it. Something called Show and Tell, which is for, supports image captioning. This was just the graph was open source, not the trained variables. You have to train it yourself if you want to use it. Something called Parsing McParseface, which does syntax diagramming, like you probably had to do in grade school, and a little bit more besides. Text summarization, and a few more fun things as well. Okay, so just to kind of give the flavor of some of the big substantial models that people are building with TensorFlow. Okay. So that's probably not very readable to you guys. So what is TensorFlow? You essentially build graphs. Often they're called model graphs, and you build these graphs to operate over tensors, which are high-dimensional matrices, n-dimensional arrays, using these flow graphs that you build. Data flow computation framework, as it is. So TensorFlow has a lot of nice features that make it nice to use for these kinds of tasks. It has a nice distributed runtime model, so you can run it on multiple CPUs, and if you use one nice thing, incidentally, about the CloudML platform, Google's CloudML platform, is that it makes it a little bit easier to do that. But TensorFlow itself is open source. You can build your own distributed runtime. For example, you're running it on Kubernetes would be one way to approach that. And you can. It has a lot of nice support for the things that you need to do to run distributed training efficiently. It has support for auto differentiation, which I'll talk about a little bit more, which makes it really straightforward and easy to define how and run your model training. And you can run it, you can train it on all sorts of different chips, and you can run it wherever you like. So if you do a little bit of search on TensorFlow.org, you'll find a tutorial that talks about, once you've trained your model, how can you run it as part of a mobile app. And what you need to do to compress it down so that you can do that. And one nice thing about doing that, of course, is it can be offline, right? You've already trained your model. Now you don't need to talk to any server to use your model to do research. So you can just run it as part of it. Okay. So let me talk just a little bit more about TensorFlow itself. And I'm going to try not to spend too much time on these intro slides because we don't have much time altogether. But I think if you sort of don't have a little bit of a sense of what it is, it's kind of hard to see what you're doing once we start playing. Okay, so the name TensorFlow, again, tensors are these multi-dimensional arrays, and they sort of conceptually flow through this graph of operations when you build a TensorFlow graph. So when we start actually working with tensors, something to be aware of is that this is how, when you look at the code, this is how they're going to be described in terms of these shape vectors. So what this means, so if we take a step back and think about a much smaller dimensional matrix, like you probably all learned in linear algebra in school, you're working with like 2x3 matrices or something like that. So 2, 3, that's the shape of the matrix. And so something like this means a matrix that's 10,000 by 256 by 256 by 3. So tensor shape. All right, and then computation is a data flow graph. And so the nodes of the graph are operations. And Some of them are sort of like, simple linear algebra operations like matrix multiplication. Some of them are more complex. There are a lot of neural net operations. I'll show you the API page listing for those in a second. That you can use as you build your neural nets. So nodes in the graph are those operations, and the edges on the graph then conceptually are these tensors that flow between the operations. The operations are applied to the tensors. But the graph nodes are not just operations, they can also be variables, and they can be outputs, they can be graph outputs, and they can also be graph inputs, something TensorFlow calls placeholders. So we'll see that in action shortly. You're defining a neural net model, and you want to be able to specify how does your data feed in. You do that by these simple placeholders. And here's an example of one class of variable that you often would use when you're building a TensorFlow neural net model. You want to define weights and biases from your model that you want to update as part of your training process. So TensorFlow is actually a data flow graph that includes state. So we'll see that shortly. And so you can define operations that essentially are update operations that update the variables that you want to learn as part of your training process. This maybe is a little too abstract, but we'll see a TensorFlow program that hopefully makes this more clear. Okay, so when you're writing TensorFlow code, you first build your graph, and the act of building it doesn't run any computations. So you build it, you can build it in pieces if you want, and then you run it. And you can build a big graph and run only one part of it if you want. You run graphs or subgraphs in what are called sessions. So this is a really common pattern that you'll see in TensorFlow programs. You define the graph, and oftentimes people kind of define it in semantic chunks, putting it together piece by piece. And then they'll create a session, and they'll run the training in that session. And then they'll use the result, the trained model, for prediction. Okay. And this is just a cute animated GIF that kind of illustrates that, but I don't think you guys can see it very well. Okay, so just to say a little bit about deep learning. Deep learning is a very trendy or buzzworthy phrase these days, but you can think of it as essentially just building large, many-layered neural nets. So there have been a lot of technical advances, both hardware and software-wise, and with respect to the data that we have access to these days, that have made it more feasible than it used to be, say, 10 years ago, to build very large neural nets and train them in a reasonable amount of time. And so when people talk about deep learning, that's typically what they're referring to, building very large neural nets with many, many of these layers, and using a lot of data to train them. And so often, sort of the crux of getting these deep neural nets to work well, and what they're kind of doing under the hood, is at different layers of the neural net, they're learning different kinds of abstractions. So that if you, to take this example of learning to recognize cats versus dogs, and we built a big neural net to do that. And typically what happens with these kinds of networks is that at the very bottom few layers, you're just learning very low-level features, like, this is an edge, this is a little corner of something, this is a little, round arc. And then as you go up those neural net layers, you start to learn more and more abstract features that, and you're not telling the network what features to learn. It is learning more abstract features that are useful to it for solving the problem that you have given it. And so, up near the top of this stack, you're going to start to learn things like, oh, this looks like an eyeball. It looks like a cat eyeball. This looks like an ear. Things like that. And you can actually leverage the higher level abstractions. You can actually tap into them and play around with them in fun ways. And that's what was going on with the, if any of you saw in the press, this Deep Dream stuff that was released. It was essentially tapping into an image classifier, a trained neural net, and leveraging it in fun ways. Okay. And I don't have time to visit the site, but you can do it on your own time. Playground.TensorFlow.org. Really, really fun for just kind of playing around with simple neural nets and seeing interesting visualizations of how they're working as you tweak the parameters. And just kind of as an aside, it's like an amazing piece of feat of engineering that they even got it to work in a browser the way it does. So really, playground.TensorFlow.org. Okay. And this is like really not showing up at all. But if you could see it, you would see that it's like a very shrunken neural net that starts here and goes all the way to here, and it has a bunch of stuff. And this is like a couple of generations ago of the so-called inception model. It's not even the most current, most complicated one. So the inception model was something that Google built to do image classification again. They open sourced a version of it. And the intent of this, if you could see it, would just to sort of to give you a sense of how complex it was. And for those of you who are more familiar with machine learning, so this would be your slides, of course. The nodes are annotated with what kind of operation you're performing. So, for example, softmax, doing convolutions, doing the max pool operation, etc. So it's interesting to take a look at if you want to in the slides. All right. So now I'm going to give a super brief overview to some neural net concepts before we jump into the code. And let me say, let's make this pretty informal, so you guys just feel free to interrupt me anytime if you have questions. All right. So you can think of machine learning kind of very broadly as a way of getting insight from, one way of getting insight from data. And here's I came up with a few different definitions. You could probably ask 10 different people what machine learning is and get 10 different answers. So a few of my life. Gives computers the ability to learn without being explicitly programmed. That's a nice way to look at it. Another nice way to look at it is you can think of machine learning as programming with data instead of instructions. So you give it a lot of data. The computer learns from that data so that it can react directly to new data. And then I just wanted to point out this nice paper as well. Machine learning is so trendy right now, and deservedly so, but it's not a panacea for everything, and it's not sort of a magic bullet that you can always successfully use without kind of like digging into it, really understanding what you're doing. And this is a nice paper, the Machine Learning, the High Interest Credit Card of Technical Debt, which kind of a few battle-scarred machine learning researchers wrote that, you kind of like throw a little bit of cold water on all the trendy PR that's around machine learning these days. Okay, so what is a neural net? Here's a highly abstracted version of kind of like one neural net architecture. There are many different neural net architectures. This is kind of a common, this is kind of suggesting a common one, often called feed-forward neural net or fully connected neural net, where you've got input nodes, you've got output nodes, and then you've got some number of so-called hidden layers connected like this. This slide is just showing one hidden layer, but oftentimes there can be more. And you give it an input, which in this case is some text. This movie was great. You run it through your trained neural net, and you get an output. In this case, this is saying positive, suggesting that your learning was with that text indicating a positive or negative movie. And in addition to classification, you can learn, your neural net can learn numerical models. So this is kind of suggesting that you've got the same input, this movie was great, and it outputs 0.7, the score. Okay. You can give your neural net all sorts of inputs, not just text, of course, and one very common type of input is image data, audio data, video data, also very common. So this is just suggesting, you can't have a talk without some cat pictures, I guess. So this is suggesting, you feed your cat picture in, and if you're lucky, your trained neural net will output cat. Okay. So how do neural nets learn? Won't go into this in detail, but there's a technique called backpropagation, which is very commonly used. So what with backpropagation, what you do is you start at your output layer, and you compare with when you ran your input through your neural net. You look at the output you got, and you compare it to the output that you wish you had the correct answer, so that this is supervised learning, and you adjust the weights of your neural net in a direction towards improving the answer a little bit. So as you adjust the weights, it gets a little bit closer to the answer you wish you had, and you make that adjustment backwards, working backwards from the output backwards through your neural net. And so that's why it's called backpropagation. And there are different algorithms for how you make those adjustments. For example, a very common one is called gradient descent, or some variant of that. And so there are different ways to decide. You need to find how are you going to compute the differential between what you have and what you would like, and how are you going to make the adjustment. So TensorFlow is really efficient at doing this, and makes it very easy. It's all kind of done under the hood. So because because it knows the entire graph of your computation as you have defined it for it, it can automatically use the back propagation and compute the gradients to figure out how to adjust your variables in the direction that they should be adjusted, given the so-called cost function or loss function that you have to find. So this is something that makes TensorFlow really nice and easy. Okay. Any questions so far? Just a few more things before we jump into the code.
So TensorFlow decides the back propagation based off the cost function?
You give it the cost function, and you give it the optimization function.
Okay.
Stochastic
And
gradient.
it decides on
And it's given the cost function that you want to minimize and the optimization function that you have told it to use. It does those things.
So can you tell me a little bit about what thin layers
Yeah, I won't be able to spend, I wasn't going to spend too much time, but I will say a little bit more about that coming up. Okay. Yeah, unfortunately, just because of the time constraints of this workshop. But I can point you to it. In fact, I think the slides have more resources too. Yeah, okay. All right, so just a bit of terminology, kind of to his question about what do hidden layers often look like. So when people talk about doing linear regression, and you can't see those little yellow dots very well, but they're often, yeah, there's a group of yellow dots here that probably none of you in that can see. So linear regression is basically trying to fit a line with an equation that looks like this to your set of data. And so if you're lucky, you're relatively good fit, kind of like this. When people refer to linear classification, it's typically applying apply a so-called logistic function to this formula. So that's what the L is here on the end of this formula here. And what that lets you do is to essentially map a line through your data set, so that you try to find where can you plot the line so that you can organize your data into two groups. I went over that super quickly, and I'm not going to say anything more about it at this time. Sorry, but that's sort of like the gist of what's going on with linear classification. And so, a so-called when people talk about feed-forward neural nets, which is a very common type of neural net, or often called fully connected neural net, that typically each layer is doing something like what I just showed. So typically each layer is doing say linear classification, where you've got your inputs, you've got your connections going out from those inputs with weights on each of those connections. You add a bias, and you often apply a logistic function on top of that, and you get your output. And so if you think about how does that look in terms of linear algebra, it's just a big matrix multiplication that looks something like this. I hope you guys have found the slides. It'll probably look a little more readable there. So,
what is the bias in favor?
and
What is the bias in favor of
bias, like if we go back to this equation, it's kind of just, so in a sense, it's another variable. It's like, how's the line shifted? So in terms of a neural net layer, the so-called bias, so the two things, typically the two things you learn with this kind of neural nets are for each layer you learn the weights, which are these values here, and then you learn these biases. And people just found that learning, expressing and learning both those things, as well as often applying a transformation, just give you better results. I mean, so that's just kind of what people typically do with neural nets. So again, each layer then is going to be a matrix operation that kind of looks like this.
So is bias more like, could it be a function, bias itself?
No, it'll be a variable that you're, along with the weights. So yeah, so again, typically, so if you have a neural net with multiple hidden layers, for each one, you'll be learning weights and biases for that layer. And again, just to kind of be clear, this is not the only neural net architecture out there, but it's a very common one. So with these feed-forward neural nets, then you can think of what we're trying to learn for each hidden layer, then as just matrix multiplication, kind of overly simplifying it then, with weights and biases that we're trying to learn, and then applying a transformation to that. So you'll see that show up in the code as we look in the code. Okay. Some other links if you want to pursue some of these further. All right, so finally, I tried to strike a balance between not spending too much time on that stuff and telling you enough to make it understandable. Okay, so finally, let's start looking at the code. And here's, you're going to start to get hands-on with this in just a second. So first, let me walk you through this code. And if you want to play along, go to the repo that I pointed you to, and go to workshop sections, and then look for starter TensorFlow graph. And then look for TF matrix mol.py. Okay? And if who's familiar with Jupyter notebooks or iPad notebooks? Okay. If you're familiar with notebooks and would like to play along in a notebook instead, then I don't know why you can see this. Look for in that same directory. Look for tf matrix mol.ipynb. And if you follow the installation and instructions that were in the GitHub repo and installed the Jupyter library, you should be able to do something like this. Jupyter notebook, and then just tell it the current directory. Give it, as the current directory, give it starter TF graph. Actually, let me change that. And running on localhost port 8888 will be a Jupyter server. And you can click on that notebook and bring it up. Okay. And if you do that, you'll need to tell it to use the right kernel that has your TensorFlow stuff installed. So I'm in my setup, I'm using the Conda virtual environment. And so if I go under kernel, change kernel, I'm going to pick one of my TensorFlow environments. And if you don't do that, then you'll get errors when you run this and you try to import. Okay, so I'll come back to that notebook in just a second, but let's take a quick look, because I think this is coming out a little bit readable on the projector, at the different parts of this. Okay, so that we're gonna define and run a simple TensorFlow graph. So this is not a neural network. This is just doing matrix operations. So first, I'm going to import NumPy and import TensorFlow. Then here, this is just creating a constant. TensorFlow understands NumPy arrays natively, so you can just use them. So here we're creating a NumPy array. And so it's just a constant. We'll see how we use it in a second. Okay, now here we're creating an input placeholder. Okay, so this is an important concept in TensorFlow. And this is how you get basically get data into your graph when you run the graph. So we're going to define a little graph that does some matrix operations, and then when we run it, we're going to say use this input to run, and we're going to do it through this so-called placeholder. Okay. All right. Then we're going to define a variable called M2, and so we. Let me go back to the placeholder for 1 second. An important thing to note about this placeholder is we just gave it a shape, right? So we're not defining the data we're feeding into it yet. We just gave it a shape. And remember, I talked about shapes earlier. So this means this is a 4x2 matrix. So as you'll see a little bit later, those of you who are maybe a little more familiar with building neural net models are probably thinking, well, you know, if these are input placeholders, and I don't know how big my batches of data are going to be, how can I define the shape already? Because maybe I get a batch of like 100 data elements, maybe I get 200 data elements. The answer to that is that when you're defining these placeholders, you can have you can tell it none, for example, as the first argument or the first element in the shape vector. So we'll see. So you can define a placeholder with a shape that is not entirely specified ahead of time. All right. Then we're defining a variable, M2, and we're saying it's of shape 2 by 3, and we're just initializing it with uniform distribution values, uniform distribution between -1 and 1. So that's a variable, and we're defining how it's initialized initially. And then here's an operation. So here we're essentially defining a node in our TensorFlow graph. So now maybe it's kind of starting to make sense that as you do these steps, you're defining a graph. We're not actually running the graph yet, we're just like building the graph piece by piece. So here's a node in our graph. And this is just a kind of like a convenience handle to the node in the graph. We're going to call it M3. And it's doing a matrix multiplication of M1 input by M2. Okay. So that's our TensorFlow graph. It's pretty simple one. And then before we actually run it, we're going to add one more node to the graph. So this is again adding a node to the graph. It's something that initializes all the variables, and you have to do this before you run a TensorFlow graph. Just to make things more exciting or confusing, one or the other. The name of that has just changed in the latest release of TensorFlow. It's now this is you'll get deprecation warnings. It'll still work for a long time, but instead of initialize all variables going forward, oh, you can't even see that gray. Something called global variables initializer instead. You'll see the deprecation warning tell you that if you're running TensorFlow 20.2. So again, it's changed, but this will work for a long time still. Okay. All right, so we've defined our simple little graph. Now we want to run it. So you always run a graph in a session. And so it looks something like this. There's kind of different ways to run in the context of a session, and I'll just show this one for now. So with TF session as session, we're basically running the init node, and that initializes the variables. So you always have to do that if you want things to work as you intend. And then we're defining a dictionary that is going to specify the inputs for all of our placeholders. So in this case, we just had, let me go back here, we just had the one placeholder. We defined this constant, M1. These are its values. We define this input data placeholder, M1 input. And so now, when we run the TensorFlow graph, we're going to say, all right, what input are we going to use for our placeholders? You need to do that as part of running the graph for any placeholders that you have. So here, we're calling session.run. We're passing it in an array of our of nodes in the graph that we wish it to evaluate. In this case, only M3. So we're saying evaluate M3, and then we're passing it the feed date, which is the mappings from placeholders to the inputs that we want to use for those placeholders. In this case, we're just saying for M1 input, we want to use this M1 concept that we defined. Okay, and then so session.run is going to evaluate the nodes that you asked to be evaluated, and in this case M3, and it's going to give you the result. And so this is such a simple example that there's something kind of interesting going on here that is not immediately obvious. And that is with TensorFlow graphs, when you call session.run, you don't have to evaluate this whole big graph that you might have defined in some real world example. You're passing it a set of graph nodes that you want it to evaluate. And it's only going to do the computation necessary to evaluate those nodes. And so you can imagine that if you have some big graph, and not everything is a dependency of the nodes that you ask it to evaluate. It's not going to process the whole graph. It's going to just going to evaluate what it needs to give you the evaluations for the nodes that you asked for, and it's going to require inputs for any placeholders that are a dependency of evaluating those nodes. Okay. So we just saw some use of some core TensorFlow concepts, and as simple as this was, did a pretty good job of showing how you build a graph. So you saw how you kind of build it piece by piece using TensorFlow operations like matrix multiplication. And we saw the use of operations, like matrix multiplication. We saw the use of variables and placeholders, saw the use of tensors, and we saw that we run the graph in the context of the session. Okay, so finally, and let's do this before we take a little break, because it'd be a good stopping point. Finally, a little bit of hands-on stuff. Let's see if you guys can, first of all, successfully run this program, and then modify it to add another operation to the graph. Okay, so first, just kind of as a standing check that your installation went well. Change to, so this is in the GitHub repo, change to workshop sections, starter graph. And you can try running this either in the IPython notebook or just from the command line. And run this script, TF matrix multiplication. Okay, and what you should see is something like this. And if you get an error, it's probably because you forgot to activate your installed virtual environment in your shell code. So I guess that would be a very common reason to get the error. Okay, is everyone, and so again, this is kind of a good sanity check that you got TensorFlow installed. Is everyone, okay. And if you're running TensorFlow 0.12, you'll get a complaint about that method deprecation that I was mentioning earlier. I'm actually running TensorFlow 0.11 because I got tired of looking at those deprecation complaints. Okay. So now let's try modifying this little script, or again, you can do it in your notebook, to do something else. And we'll make it, just for the sake of keeping things simple, we'll make it a matrix addition. Okay. So try going and modifying that graph. Add another node to the graph that adds M3 to itself. Store the result in M4, and then return the results for both M3 and M4. So that means that when you call session.run, you'll ask for both M3 and M4 to be evaluated and get the results back. And so a good thing to look at when you're trying to do this is the TensorFlow API docs. So this is a good time to visit that page. So I'm at tensorflow.org. I'm under the API here. And you can't see any of this very well. But look for, you can actually do a search down at this left nav bar, which has basically everything. Look for math. And look for how you would do matrix addition. I'll give you just a little time to play around with this. The slides are, so this is the not so short link. I don't know. Okay, and I think maybe, just thinking about the timing, why don't we take kind of like an informal break? Let's see everyone back here in like, If you want, you can like separate send it to your doctor for then you put just like that. So you can have a friends meeting.
But I would have to go back into doctors.
Yeah, you're in doctor. Yeah, actually, or just try just try starting. So it's Jupiter. Good question. So the way that the way the exercise asks you to do is to do session outline and the value. So the way that you do that is you just pass both into this array of things that you want to know. And then you have to, you get the results back as they true. So now you need to, well, so it just like result one. Yeah, so, test a little bit, and then, well, you just explicitly ask for it, so result one, comma, result two. And then, in fact, I think, this is. It's always a little different, it's in random dimension. Looks like okay, I guess I'll get going again since we have such a short period of time. We're going to do this work fast. All right, so those of you who poked around in the repo might have noticed that the solution to this was actually in the same directory. Although hopefully you tried to do it yourself before you looked at the solution. So let's take a look at it and also point out a couple more interesting things that I didn't mention previously. Okay, so the goal was to add another node to this super simple little TensorFlow graph that added M3 to itself. Okay, so here is where we're doing this, and sort of strangely, the TensorFlow add is just add, not mat add, which is a little confusing. And another way that you could have done it is just use the plus operator. I don't know how well you can read that, not really at all. But you could have also just done kind of the shorthand of M4 equals M3 plus M3. And remember, when we do this, we're not running any of it yet, right? We're just defining the graph nodes. And another interesting thing that's sort of shown as part of this graph definition is this useful identity operation. So this is kind of effectively, it's an identity op. It's effectively a no-op in terms of actual calculations. That if you want, you can stick into your graph at any point just to try to debug or get information about what your computation is doing. So that's just kind of a useful tip. And you can see that we're essentially like reassigning M3 to first doing the matrix multiplication and then doing this identity op on it. And that just kind of points out that these variables, like M3 and M4, they're just kind of like pointers or handles, to the nodes in your TensorFlow graph. So there's nothing weird going on, or I should say nothing unusual to reassign a variable like that. It's just a handle to a node. Okay. So M4 is M3 plus M3. And now we want to run the graph, and we want to ask TensorFlow to evaluate both M3 and M4. And so we're going to do it like this. Session.run, and we pass it this array of nodes that we want it to evaluate. And again, our feed dict has to include inputs to any placeholders that are dependencies when we evaluate those nodes. And since we asked it for M4 and M3, we now need to get back 2 results. And then we're printing them out. And so that is the sort of the basic, you'll do this over and over again, sort of the basic model for, well, I want to evaluate part of my TensorFlow graph. I want to evaluate these nodes, giving back the answers for these nodes. And then finally, something I didn't mention previously is this eval method. So you can also use eval in the context of a session. Sometimes it's a little more convenient as opposed to session.run. But a difference would be that eval is not going to work if you need to pass in placeholder values. So for anything where you need to give inputs and pass in placeholder values, you have to use session.run and pass in what you did. Here we're just going to say, all right, what is M2? So we can do that. We can evaluate it in the context of a session. Okay. So again, this is super simple, like in the TensorFlow world, but it actually shows a whole bunch of useful concepts. Does anyone have any questions before we move on to actually doing some training?